All right, friends, let's go after these. Let's start with Jada's plan. Looking at Jada's, I'm going to start with this larger triangle. That triangle is going to be 1/2 base times height. So 1/2 times 8 times 5. Did we get 20 for that area?
Yes.
Okay, this rectangle is going to be base times height, which is 8 times 2, which is 16. Are you guys noticing some organizational strategies I'm using? Okay. And then these little triangles, their base is 4, so 1/2 of that base is 2 times the height of 1. Each one is 2. So the area total is 40 square inches. Ivy? So the way Diego did it is he started with 8 by 8, or he started with 64 total. Right? This whole square he did. And then Diego's taken away the chunks. So this triangle down here would be 1/2 base times height. So 10. That means this one is minus 10. Notice I put minus 10 on these. I'm taking them away. These little triangles are going to have a base of 2 and a height of 1. So 1/2 the base is 1. 1 times 1 is 1. So each little triangle there is going to be a minus 1. And that larger triangle up there is going to be 1/2 of 4, which is 2 times the height of 1. So the reason I'm putting minuses on there is because he's starting with the whole thing being full and cutting off those corners. So negative 24, he's taking off 24 to leave us with 40 square inches. So who was right?
Both.
Yes.
They were both correct.
They were both right? Different ones.
No, they're wrong.
I actually like this one when I have a figure that looks something like this. And then I take that out after. That's my favorite way. It's different, but the same idea, right? Good thing, what this shows is math is creative. 2 different ways, they're both wonderful. So we're going to extend that, what we just did. And here's what I want to explain to you. Okay, we already looked at this equation before for volume. Oops. Yeah. We've looked at this equation before, right? Where if we can get this chunk filled in and multiply by the height, we'd fill in the whole thing. Right? So that's what you're going to try to do. We're going to start with this portion of the prism. Make sure you read the directions. Let's go. So for this one, I personally chose to make it into a rectangle and a triangle. My rectangle was 6 by 7 for 42. And my triangle was 1/2 times 6 times 4. The 4 was tricky because the 4 wasn't listed, right? The whole thing's 11. So if here to here's 7, to the tip needs to be 4 because 7 to 4 is 11. That 5 is this right here, which is not the height of the triangle. Okay, so the triangle has an area. The triangle has an area of 12. Are you guys seeing that you don't need that 5? That's not to trick you, by the way. In the real world, when we see math, there's more numbers. There's like infinite numbers in a situation. It's our job to pull out the numbers we need. Okay? So it's not like a gotcha thing. It's like really, we need to sit there and think, what numbers do we need? So that means the whole area of this part of my prism is 54 square units. And how do I know that is my area? What communication did I use to say this is my area, Ivy? Okay, but what like if you look at this number right here, square units, I'm on that. You're going to lose points on tests if you don't have it because it is important. This tells me this area. Now, to just take that one face of my prism and fill in the whole thing, what am I going to do with that 54? Multiply by 8, right? I'm going to fill it in that direction. You can kind of imagine filling it in over and over and over and over, fill it in. So 54 times 8.
That would be
432. And then what about this number tells me that it's volume? Yeah, right. cubic units, right? 3 dimensions.
Yeah, that makes
That's communication, friends. So things I want to point out. Did you see me use organizational strategies? Yes. Did you see me label things?
Yep.
Yes. Did you even see me throw it into an equation? Write some equations down? Yep. That's all communication. That's all organization. That's all problem solving. Okay? I think I told you before when I was in 8th grade algebra, I was not doing those things and I would make little mistakes because there's a lot of numbers going on here, right? And sometimes we lose our train of thought or, we leave and come back to it. So organization's big on this stuff. We're going to jump right to the wheelbarrow problem. You can see this cool old school wheelbarrow. I'm guessing it's from a McDonald's, but I don't know. Okay? I'm guessing it's from McDonald's because it is yellow and red and there's a Happy Meal toy in it. But just a guess. Who knows? Who knows? Anyway, we're going to go here where you have dimensions of this wheelbarrow. And your job is this. How much concrete can we hold in that wheelbarrow? Don't worry about that little stuffed animal there. That's coming out first, okay? And then when you pour it out, I don't know, has anybody ever poured concrete out?
Yes.
There's a little film left in it.
Not fun.
It's fun. There's a little film left in it, and so it's going to be your job to kind of figure out what that film is after you dump it out. Let's get after it. I'll let you know, as I walked around, I saw a lot of people cut it right there and do 3 chunks. Or some people do all this and then take off 2. I'm going to let you know there is a trapezoid equation. So let me show you something. And it's a fun equation. So let me just draw a trapezoid.
We can't see it.
Yeah, we can. Yep,
Oh.
Okay. Here's a little trapezoid, okay? Now, 2 parallel sides. Okay, and it's a quadrilateral. There's lots of different trapezoids. This works for all of them, okay? Now, here's what the equation does. Let me show you first the visual. What I'm going to do with math is I'm going to make this side a little longer, this side a little shorter, and make it into a rectangle. And that'd be beneficial because a rectangle is just base times height. You guys all see that I could take that, throw it up there, and it'd fit? I mean, this isn't like the perfect drawing, but you're getting the gist. So here's the equation that does that for a trapezoid. In a trapezoid, we have 2 bases. We'll call them base 1 and base 2. And we have a height, the distance between the bases. So in this trapezoid, we've got a base 1, a base 2, and a height. So what we can do to make the 2 bases the same length with math, it works for this one too. We can make this one a little longer, this one a little shorter, this one a little longer, this one a little shorter, okay? And it does it too. How we do that is by taking the average of the bases, right? If I add the 2 bases together and divide by 2, I get 2 bases that are the same length then. Okay, guys, so let's imagine this is a 4 and this is a 6. If I add those together and divide by 2, I get 5. So this one would be 1 more, this one would be 1 less. I have my math made it into a rectangle. Then I just need to multiply that by the height. So that's how I have it stashed in my brain noggin. Average the bases, gives me a rectangle, times the height. It's really cool. So I lean on this a lot. Instead of making a rectangle and a triangle, I almost always use the trapezoid equation. The average of the bases times the height. Checking this out, I personally would just do the trapezoid, the whole trapezoid, which would be area equals the average of the bases, so 40 plus 140, times the height, which is 66. So this would give me the area of the whole trapezoid. So even if you bust it up into smaller things, 90 times 66, I've got 5,940. 5,940. And that's going to be square centimeters.
No way.
And that's for just the trapezoid. That's for just the trapezoid. Now, to fill in my figure, I need to take this trapezoid and do what with it? To fill it in, how am I going to fill in my wheelbarrow now? This is just one side of my prism. Yeah, I'm gonna send it that way by times 70. So 5,940 times 70. I'm doing it in my head right now. 415,800.
Let's go. Oh, I got that.
And that's going to be cubic centimeters because it's volume. All right? So, stay with me. Does everybody see that visual of multiplying by the distance between the two bases? You can like see it, fill it in. The math is what happens there. Now, we got to dump this concrete. And so we need to get surface area. So stay with me on this. I think the easiest part of surface area, there's an equation for this, is this portion. There's two bases, right? This trapezoid's on the front and the back. Both will be full of concrete. We good with the two bases?
Yes.
Yeah, so that's the two bases part of the equation. So for our purposes, we have 2 times 5,940 for that. We got those. Now there's more to that though. And let me show you the visual. I'm going to do it the best I can on here of how I like to think of the other parts. I think of it kind of like a cookie cutter that I'm pushing through it. So if I can outline this, just the outline, not the inside. Well, that wasn't pretty bad. And then shove the whole thing that way, that would give me the distance around. It wouldn't give me the bases, it would give me everything else. Imagine it's just the outline. Or imagine this trapezoid like this, goes on a 3D printer base, and just outline over and over and over. That would be that other area, the lateral area. Not the bases, everything but the bases. So we're going to take the perimeter of the base times the height, and that'll give me everything else. So in this case, the perimeter of the base is, let's see here, 140, 180, plus 93, plus 74. So 347. Is that what you guys got?
I did not finish. I didn't get that.
So let's double check that. 140 plus 40 is 180. 180 plus 93 plus 74. 347. So here we're going to do plus 347. That outlines our trapezoid, just the outline. And we multiply that by the distance between the trapezoids. That gives us everything else. So that's going to be times 70. And what that gives us is 2 times 5,940 plus 347 times the 70 to fill it in. 36,170. But if you think about the wheelbarrow, what part is not going to have cement on it still?
The top.
The top. So we're going to take the top away. What we just did filled in the top, but we need to take the top away. So the top is 140 by,
70.
right here, 70. So I'm going to take away 140 by 70 just to take the top off. And I'll recap us. 26,370. And this is going to be square centimeters. So again, here's what happened with our math. The two bases. Everybody good with, there's a two base, the trapezoid on the front and back?
Yeah.
We got those.
We got them.
Then we outlined one of them, the perimeter of it, just the outline. And we did the perimeter that way. That gave us all the other sides, all the rectangular faces, right? So you can't see this on the video, but like, you know, if you made a trapezoid or like a square with your hands, and you just did the outside portion, not the two bases. Well, I'm doing the Illuminati symbol. But if you just did that, it would not do the two bases. You're just doing the outside. That's the whole point of getting the perimeter. Yeah, Ivy.